master. Today we are going to do exercise 12.2 of class 10th of State Board of Telangana and Andhra Pradesh. So let's move on. For any notes you can directly scan this QR code. And now we will move towards the first question. The first question is, a TV tower stands vertically on the road on the side of a road. From a point on the other side directly opposite to the tower, the angle of elevation of the top of tower is 60 degrees. From another point 10 meters away from this point, on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. Find the height of the tower and width of the road. So, here first thing is given that there is a TV tower standing vertically on the ground. On a side of a road. From a point on the other side directly opposite to the tower, let's say here, the angle of elevation of the top of the tower is 60 degrees. So let's say this is 60 degrees angle of elevation. From another point 10 meters away from this point, this distance is 10 meters, and on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower will be 30 degrees. Means this is the line of sight and this is 30 degrees angle, and this is 90 degrees because it is standing vertically on the ground. Find the height of the tower and width of the road. So we will now keep the name of the points. This as point A, this as point B, this as point C, and this as point D. And we will let this as H as height and this as W as width. So we have let CD is equals to height or H, BC is equals to width or W. So what now we should do is, to find this we should take we want this value and this value for starting. First we should start with it, and in these two right angle triangles we have CD common in both. So the thing we will do here is, we will find the value of H by using tan theta which covers the base. So we can find the value of W. So now we will firstly go with from triangle BCD. Here from triangle BCD, tan B is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to, what is opposite of angle B in triangle BCD? It is CD upon adjacent, which is BC. Now what we have let CD, it is H, and what we have let BC as W. So I know that tan B is equals to H upon W. So instead of B I can write its value 60 degrees. If tan B is equals to tan 60 degrees, then B should be equals to 60 degrees, and our B is equal to 60 degrees. So tan 60 degrees is equals to H upon W. So 1 upon root 3 is equals to H upon W, and after that we will get, sorry, not 1 by root 3, the value of tan 60 degrees is root 3. So from here our value of H will come as H is equals to root 3 W. So from here we have found this. Now from triangle ACD, this triangle, we will find tan theta, which covers these both and these both, and the reason I have told you. So from triangle ACD, tan A, our theta is A over here, which is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to, for angle A is CD, perpendicular is CD and base is AC. So this will be CD upon AC. So now I can put the value of CD as H upon. So I can write AC as A plus B, sorry, AB plus BC. I can write this. So I will write it as AB plus BC. AB plus BC, which is equals to H upon, what is AB? AB is 10 meters and BC is W. AB is 10 meters and BC is W. So this is 10 plus W. So our tan A is equals to H upon 10 plus W. And now instead of A, I will take the real value of A, which is 30 degrees. You can see here the real value of it is 30 degrees. So now if tan A is equals to tan 30 degrees, then angle A should be equals to 30 degrees. So our angle A is equals to 30 degrees. So I wrote it as tan 30 degrees. Tan 30 degrees is equals to H upon 10 plus W. Now what is the value of tan 30 degrees? It is 1 upon root 3, which is equals to H upon 10 plus W. Now root 3H is equals to 10 plus W. And from here we get the value of H. H is equals to 10 plus W upon root 3. So we have got this value, and this is also an important value. So now what we will do is, now we will say H is equals to H. So we will write the first value of H, which is this root 3W. So root 3W is equals to, what is second value of H? It is this 10 plus W upon root 3. So this is equals to 10 plus W upon root 3. So root 3 will go that side, and this will be 3W is equals to 10 plus W. And this will be 2W is equals to 10. and then W is equals to 5 meters. Just a second. Meters. So this is the actual answer. Now we have found the width of the road. Now we have to also find the height of the tower. So we know that h is equals to root 3w. Now we know the value of w. So h is equals to 5 root 3. The value of w. So the height of the tower is 5 into root 3 meters, and the width of the road is 5 meters. So we will move towards the next question. This is the next question. A 1.5 meter tall boy is looking at the top of a temple which is 30 meters in height from a point at certain distance. The angle of elevation from his eye to the top of the crown of the temple increases from 30 degree to 60 degree as he walks towards the temple. Find the distance he walked towards the temple. So it is, in the question there is given that there is a 1.5 meter tall boy looking towards the temple which is 30 meters, and now the angle of elevation from his eye to the top of the crown of the temple increases from 30 degree to 60 degree. Means at first he had 30 degree angle of elevation. So this is 30 degree angle of elevation over here from his eye. So there is a rectangle formed here. So this will be also 1.5 meters. And if this is 1.5 meters, then the above length will be 30 minus 1.5, which is equals to 28.5 meters. So the height of this will be 28.5 meters. And now after he walked, the angle of elevation became 60 degrees. So we should find the distance he walked towards the temple. So we will firstly name the points. This is A, this is B, this is C, this is D, this is E, this is F, this is G. So now what we have to do is we should find CD. So to find CD, the thing we have to do is we should first take the value of BC from triangle ABC. So from triangle ABC, tan C is equals to perpendicular upon base, which is also equals to opposite upon adjacent. For angle C, it is equals to AB upon BC, which is equals to the length of AB is 28.5 and length of BC is BC, just BC, we don't know. So tan C is equals to 28.5 upon BC. So instead of C, I can write the real value of C, which is 60 degrees. So tan C is equals to tan 60 degrees. So C must be 60 degrees, and it is. So tan 60 degrees is equals to 28.5 upon BC, and the value of tan 60 degrees root 3. So root 3 is equals to 28.5 upon BC, and now the value of BC is equals to 28.5 upon root 3. This is the actual value of BC now. So now we have found BC. So while we will take tan theta, which covers this perpendicular AB and covers this distance BD. So we can say BD is equals to BC plus CD. Okay, BD is equals to BC plus CD. So we can put the BC value and find the CD value. So now from triangle ABD, here you can see the triangle ABD. Tan D is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to, this is our angle D. So what is the perpendicular? 28.5. No, first we will put AB. This is AB upon what is adjacent here. Adjacent is BD. So the value of AB is 28.5, and instead of BD we can put this value BC plus CD. So this is BC plus CD, which is equals to 28.5 upon what is the value of BC? 28.5 upon root 3. So this is 28.5 upon root 3. Just a second. Okay. Now we will not put the value of, we will let it just as BC plus CD. We will let it just as BC plus CD for now. So tan D is equals to 28.5 upon BC plus CD. So instead of D, I can put the real value of D, which is 30 degrees. If tan D is equals to tan 30 degrees, then D should be equal to 30 degrees and D is equals to 30 degrees. So tan 30 degrees is equals to 28.5 upon BC plus CD. So what is the value of tan 30 degrees? It is 1 upon root 3, which is equals to 28.5 upon BC plus CD. So after cross multiplying, the thing we will get here is, just a second, 28.5 into root 3 is equals to BC plus CD. So 28.5 into root 3. Now this is the right time to put the value of BC. So the value of BC is this. This is the value of BC. 28.5 upon root 3 plus CD. So So now what we should do is for better understanding we will take like this. The value won't change, but just let us take like this. So now we will put this side in minus. So CD is equals to 28.5 into root 3 minus 28.5 upon root 3. So now I can common 28.5 from here, and the remaining will be root 3 minus 1 upon root 3. And if we take LCM over here, it will come 3 minus 1 upon root 3. Then CD is equals to 28.5 into 2 upon root 3. So now we have got CD is equals to 28.5 into 2 upon root 3. CD is equals to, now if we multiply 28.5 into 2, it will be 57. So this will be 57 upon root 3. So CD is equals to, instead of 57 I can write 19 into 3 upon root 3. So CD is equals to 19 into, instead of 3 I can write it under root 3 square, because its product is 3. So we have in denominator we have root 3. This root 3 and root 3 will get cancelled, and the answer will come CD is equals to 19 into root 3 meters. So this is the length which he walked towards the temple. So now we will move towards the next question. A statue stands on the top of a 2 meter tall pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees. And from the same point, the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the statue. So now when we draw a flag like this, we draw a flag, but we don't see what is down here. We will draw something like this. This thing is called pedestal. So this is not a part of statue, but it is helpful in for the base of the statue. So a statue stands on 2 meter pedestal. So this is the pedestal and this is the statue. From a point on the ground, the angle of elevation to the top of the statue is what? 60 degrees. This is 60 degrees. And the angle of elevation of the top of the pedestal is 45 degrees. So now I will make some convenient diagram. So from to pedestal, this is 45 degrees angle of elevation. So find the height of statue. So we will let this height, this is the height, this is just 2-meter pedestal. And now the distance between them we will let it as x, and now we will name the points A, this is point A, this is point B, this is point D. So we have let CD is equals to H and AB is equals to X. So now I can see two common things in this two right angle triangle, which is one common thing, which is AB. So we have named AB as X. So from the right angle triangle ABC we will find the length of AB. So from triangle ABC, now what trigonometric ratio we should use, in which perpendicular and base is involved, that is tan theta. So tan A is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is here equals to BC upon AB. And what is the value of BC? It is 2 meters upon the value of AB is X. So I can say that tan A is equals to 2 upon X. And instead of angle A, I can write the real value of angle A in triangle ABC is 45 degrees is equals to 2 upon X. So what is tan 45 degrees? It is 1. 1 is equals to 2 upon X. So the value of X will be 2 meters. So the distance between the point and the bottom of pedestal is 2 meters. So we have to find now the height of the statue. So now we will use the another triangle, because we have got the whole length of one thing, and now we will take tan theta once again because perpendicular and base is involved in this. So from triangle ABD, tan A, here angle A, in this triangle it is this, in this triangle it is this, observe. So tan A is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to BD upon AB. BD upon AB, which is equals to, what is BD? BD is H plus 2, or for better understanding, I will write BD as BC plus CD. BC plus CD upon what is AB? AB is X, and we have found the value of X, which is 2 meters. This is 2 meters. So this is 2. So what is BC now? BC is 2 and CD is H. So BC is 2 plus CD is H. 2 plus H upon 2. So tan A is equals to 2 plus H upon 2. Now instead of angle A, I can write the value of A, which is 60 degrees. Tan 60 degrees is equals to 2 plus h upon 2. If tan A is equals to tan 60 degrees, then angle A should be equal to 60 degrees. And angle A is equals to 60 degrees, so I can write it as tan 60 degrees. So the value of tan 60 degrees is root 3. Root 3 is equals to 2 plus h upon 2. And now 2 root 3 is equals to 2 plus h. And h is equals to 2 root 3 minus 2. So now how to find this value is, just we have got h is equals to 2 root 3 minus 2. Take out 2 common, root 3 minus 1. H is equals to 2 into, instead of root 3 you can write 1.732 minus 1. H is equals to 2 into 0.732 now, and the answer of H will be 464. 1.464 will be the answer. 1.464 meters is the height of the statue. So we will move towards the next question. Here is the next question. Now from the top of a building, the angle of elevation of the top of a cell tower is 60 degrees and the angle of depression to its foot is 45 degrees. If distance of the building from the tower is 7 meters, then find the height of the tower. So there is a building and there is a tower, and from the top of the building, the angle of elevation of the top of a cell tower is 60 degrees. So now here a horizontal line, and the angle which here is forming is 60 degrees. Just a second, this diagram is very small. I will make it a bit larger. So this is 60 degrees angle of elevation, and this is the ground. This is the ground, and the angle of depreciation to its foot is 45 degrees. So up to here this is 45 degrees with horizontal line. So if the distance of the building from the tower is 7 meters, means if this is 7 meters, then find the height of the tower. So now we will let this as x, this as y, and we will let x plus y as h, which is height. And now we will name the points, this as A, this as B, this as C, this as C, this as D, this as E. So now what we have to do is, we have let DE is equals to X, BD is equals to Y, and BE is equals to H. So now we will find the value of Y firstly. And one thing, here a rectangle a rectangle is forming ABCD. So if this is 7 meters, CD will also be 7 meters. So CD is 7 meters. CD is 7 meters. So from triangle BCD, tan C is equals to perpendicular upon base. It can be also written as opposite upon adjacent, which is equals to BD upon CD, which is equals to we have let BD as Y and CD as 7. So I can say tan C is equals to Y upon 7. So instead of C, I can write 45 degrees. The value of C in triangle BCD. So tan 45 degrees is equals to Y upon 7. So Y I can write tan C as tan 45 degrees. So first thing, if tan C is equals to tan 45 degrees, then angle C should be equal to 45 degrees, and our angle C is equals to 45 degrees. So I wrote it. So the value of tan 45 degrees is 1. 1 is equals to Y by 7. Then Y is equals to 7 meters. Now we don't have any triangle who has H. So we have to add X plus Y. And now we will find from triangle CDE about the X. So from triangle CDE, tan C. Now why we are using tan C here? Because the perpendicular and base is involved here. So tan C is equals to perpendicular upon base, which is also equals to opposite upon adjacent. Both are same, don't confuse. Which is equals to here, which is equals to DE upon CD which is equals to, we have let DE as X. We have let DE as X upon CD is 7 meters. You can see here. And now we know that tan C is equals to X upon 7. We know that tan C is equals to X upon 7. So instead of angle C, I can put the real value of C in triangle CD, which is 60 degrees, is equals to tan 60 degrees is equals to X upon 6. So I put once again the same. If tan C is equals to tan 60 degrees, then C must be equal to 60 degrees, and our C is equals to 60 degrees. So I wrote it. So tan 60 degrees is equals to 1, not 1 upon root 3, which is equals to x upon 7. So x is equals to 7 into root 3 meters. So now just a second. The thing we have to find actually is BE, but BE is equals to BD plus DE. You can see here. So our BE is H, you can see here, which is equals to BD is X. You can see here our BD is Y, not X, it is Y plus our DE is X over here, you can see. So H is equals to Y plus X or X plus Y. So X is equals to the value of Y. Here we have solved is 7 meters. So 7 plus, what is the value of X? It is 7 root 3 meters. So this is plus 7 root 3. So H is equals to, now make 7 common. 7, 1 plus, now instead of root 3 we can write 1.732. So H is equals to 7 into 2.732. Don't confuse here, the value of root 3 is 1.732. So I am writing it. So H is equals to, now here the value of H will be equals to it will be 19.124 meters. 19.124 meters. So this is the height of the tower. So we will move towards the next question. So this is the next question. A wire of length 18 meter had been tied with electric pole at an angle of elevation 30 degrees with the ground. Because it was covering a long distance, it was cut and tied at an angle of elevation 60 degrees with the ground. How much length of wire was cut? So now there is a electrical pole. This electrical pole, and the wire was tied. The wire was tied with angle 30 degree angle of elevation, which was 18 meters long. And after that it was cut and they made it 60 degree angle of elevation because it was covering long distance. So how much the wire was cut? So now we will name this side as H and this as N. And now we will name the points. This as point A, this as point B, this as point C, this as point D. So firstly we have let that CD is equals to H, just a second, and BD is equals to n. So now a thing is common in these both, which is h. So we can do one thing is we can first find the value of h from the ACD triangle, and after that we can substitute. Now we can, after getting the value of h, we can from triangle BCD find the value of n. So first we will find the value of h from triangle ACD. Just a second. From triangle ACD. Now, which trigonometric ratio contains perpendicular and hypotenuse? It is sine theta. So, sine A is equals to perpendicular upon hypotenuse, which is also equals to opposite upon hypotenuse, which is equals to CD upon AD. CD upon AD. So our CD is H and AD is 18 meters. So I can say that sine A is equals to H upon 18. So instead of A, I will put the value of A, which is 30 degrees. Sine 30 degrees is equals to H upon 18. So why I have put sine A as sine 30 degrees is when sine A is equals to sine 30 degrees, then angle A must be equal to sine 30 degrees. So this is sine 30 degrees is equals to H upon 18. So root 3 by 2 is equals to H by 18. And this will be equals to H will be equals to 18 root 3 upon 2. No, just a second. The mistake I have done is the value of sine 30 degrees 1 by 2, not root 3 by 2. It was the value of sine 60 degrees. So the value here will come H is equals to 9 meters. If you cross multiply them, you will get 2H is equals to 18. Then if you send at n in denominator, in right hand side it will become 9 meters. So H is equals to 9 meters. Now we have found H. So now we will find the value of N, which was asked. No, that is not asked in the question. I will tell you later when that part comes. So now from triangle BCD, this triangle, now perpendicular and hypotenuse are involving, so we can take sine theta trigonometric ratio. So here sine B is equals to perpendicular upon hypotenuse, which is also equals to opposite upon hypotenuse, which is equals to, now for angle B, the perpendicular is CD and hypotenuse is BD. So this is equals to CD upon BD, which is equals to the, what is CD? It is H upon what is BD? BD is N. H upon N. Now we have solved the value for H, which is 9 meters upon N. So I can say that sin B is equals to 9 upon n. So B is equals to, instead of B, I can write the value of B, which is 60 degrees, is equals to 9 by n. So now why I have wrote sin B as sin 60 degrees? Because if sin B is equals to sin 60 degrees, then angle B must be equals to 60 degrees. And our angle B is equals to 60 degrees. So I can write it. So sin 60 degrees is equals to 9 upon n. So the value of sin 60 degrees is root 3 by 2, which is equals to 9 by n. And this will be, and the answer will come root 3 into n is equals to 18, and n is equals to, we will take this another side, n is equals to 18 upon root 3. So what we can write 18 as? We can write 18 as 6 into 3 upon root 3. So n is equals to 6 into, what we can write? 3. We can write it as root 3 square. So what is root 3 square? Root 3 into root 3. So 3 is equals to root 3 into root 3 upon root 3. So root 3 and root 3 will get cancelled and the answer will come. N is equals to 6 into root 3 meters. But now our question, what was asked in the question is not this. The thing which was asked in the question is not this. It is how much the length of the wire was cut. So length of wire which was cut is equals to length of wire before cut minus length of wire at present. So length of wire which was cut is equals to, what was the total length of wire before cutting? It was 18. And what is the length of wire at present? It is n, which is 6 into root 3. So if we take 6 common from here, we will get 3 minus root 3. And we will get L is equals to 6 into, instead of root 3 we can write 1.732. So this is equals to 6 into 2. This is equals to 6 into, not 2 point, it will be equal to 1.268, and after multiplying, L is equals to 6 into 1.268. After multiplying, we will get 7. We will get 7.608 meters. This is the length of wire which was cut. Okay, so now we will move towards the next question. This is the next question. The angle of elevation of the top of a building from the foot of the tower is 30 degrees and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 30 meters high, find the height of the building. So, the question is given, there is a building and a tower. A building and a tower. The angle of elevation of the top of a building from the foot of the tower is 30 degrees. So, from foot of the tower to the top of the building, the angle of elevation is what? 30 degrees. This is equals to 30 degrees. And the angle of elevation of the top of the tower from the foot of the building is 60 degrees. So from the foot of the building to the top of the tower is 60 degrees. So if the tower is 30 meters high, so if this is 30 meters high, then find the height of building. So now we will let this as h, this as d, as distance, as height. So now we will name these points. This is point A, this is point B, this is point C, this is point D. So we have let AB is equals to h and BC is equals to D. So now what we have to do is we should think about a common side from these two right angle triangles, which is BC, which is D. So by finding the value of D from triangle BCD, we can find the value of H from triangle ABC. So now we will find the value of D from triangle BCD. Here also tan trigonometric ratio is involving because perpendicular and base are involving in this. So in triangle BCD, tan B is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to here CD upon BC. So which is equals to the value of CD is 30 meters upon the value of BC is D. So I can say that tan B is equals to 30 upon D. So instead of B I can write the value of B, which is tan 60 degrees is equals to 30 upon D. So now why I have wrote tan B is equals to tan 30 degrees. If tan B is equals to tan 30 degrees, then B must be equals to 60 degrees and our B is equals to 60 degrees. So I have wrote it. So the value of tan 60 degrees is √3, which is equals to 30 upon D. So D is equals to 30 upon √3, and now D is equals to instead of 30 we can write 10 into 3 upon root 3. Then d is equals to 10 into, I can write it 3 as under root 3 square. So I can write this under root 3 into under root 3 upon under root 3. Under root 3 and under root 3 will get cancelled and the answer will come 10 into root 3 meters. So after getting this answer, now we have found our distance between any tower and building. So now we will find the height of the building. So for that we have to use details from triangle ABC. We have to take once again tan trigonometric ratio over here because perpendicular and base is involved. You can also take cot trigonometric ratio, but tan is more used. So we are also taking tan over here. So tan C here is equals to perpendicular upon base, which is equals to opposite upon adjacent, which is equals to AB upon BC, which is equals to AB is H and BC is D. AB is H, BC is D. So what is the value of D? It is 10 into root 3 meters. So H upon 10 into root 3. So tan C is equals to H upon 10 into root 3. So what is the value of C? Yeah, it is 30 degrees. If tan C is equals to tan 30 degrees, then angle C should be equal to 30 degrees. So the tan 30 degrees is equals to H upon 10 into root 3. So 1 upon root 3 is equals to H upon 10 into root 3. So H into root 3 is equals to 10 into root 3. Root 3 and root 3 will get cancelled, and from this we can say the height of the building is equals to 10 meters. This is the right answer. So now we will move towards the next question. This is the next question. Two poles of equal heights are standing opposite to each other on either side of the road, which is 120 feet wide. From a point between them on a road, the angle of elevation of the top of the poles are 60 degrees and 30 degrees respectively. Find the height of the poles and the distances of the point from the poles. So what we have to do is, they have mentioned that they have two equal length poles on road, and this is the width of the road is not W, it is 120 feet. So this is 120 feet, and from a point there is 60 degree angle of elevation to the first one and 30 degree angle of elevation to the second pole. So we have to find the height of pole and the distance of the point from the poles. So now if we know this total, now first for understanding we will name the points. This is point A, this is point B, this is point C, and this is point D. So sorry. I have missed here, C, D, E. And now this total is what? 120 feet. So if I call this part as X, this will be what? 120 minus X. This will be automatically will be 120 minus X. So to find the heights, what we should do now is, first we should find the value of X, and after finding the value of X in terms of D, then we should find from another triangle, we should find the value of 120 minus, sorry, it's, oh no, now we will let these as X, this and this, because these both are same, and we will let this as D. So we will let DE and AB is equals to X, CD is equals to 120 minus D. Automatically it will be 120 minus D if BC is equals to D. So after letting these, now what we have to do is, from triangle ABC, we have to take tan C. Tan C is equals to perpendicular upon base, which is equals to opposite upon adjacent. And now here it is equals to AB upon BC, which is equals to X upon D. So we know that tan C is equals to X upon D. So instead of angle C, I can write 60 degrees, because the angle C is 60 degrees. What is angle C? It is 60 degrees. So what is tan 60 degrees? It is root 3. Root 3 is equals to X by D. So what is the value of X? It is root 3D. This is the important value. Now the thing we have to do is, from triangle CD we should find X, because this and this is common from them. So if we find X, we can find another factors easily. So from triangle CDE, we have to once again take tan C, but this is also equal to perpendicular upon base or opposite upon adjacent. But here it was about triangle ABC. This is about triangle CDE. So this is 30 degrees over here, and this is equals to DE upon CD. DE upon CD, which is equals to DE is X and CD is 120 minus D. So I can say that tan C is equals to X upon 120 minus D. So instead of C, I can write tan 30 degrees, because if tan C is equals to tan 30 degrees, then C must be equals to 30 degrees, and our C is equals to 30 degrees. So tan 30 degrees is equals to X upon 120 minus D. and the value of tan 30 degrees is 1 upon root 3, which is equals to x upon 120 minus d, which is equals to root 3x is equals to 120 minus d, and then x is equals to 120 minus d upon root 3. So now I can say x is equals to x. So we have found this value of x. I can write, instead of x, I can write this, and in second one I can, instead of that I can write this. So I can write root 3d is equals to 120 minus d upon root 3. You can see over here. So this is equals to, this will go here and multiply with root 3 and give the product 3. So this will be 3d is equals to 120 minus d, and then 4d is equals to 120, and d is equals to 30 meters. So we have, sorry, not meters. This is in feet. The unit is feet. So our d is 30 feet. So distance between first pole to point is equals to d, which is equals to 30 feet, and distance between second pole to point is equals to 120 minus d, which is equals to 120 minus 30, which is equals to 90 feet. So now and now we know that we have made two conclusions of x. First is this one, sorry, this is second one and this is the first one. So I will take easiest one for now. X is equals to root 3d. So what is the value of d? Yes, it is 30. So x is equals to 30 into root 3 feet. So this is the value of x. This is the height of the pole, and this is the distance between the pole and the point. So now we will move towards the next question. Here the angles of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters. Find the height of the tower from the base of the tower and in the straight line with it are complementary. So now here we have a tower. We have a tower over here, and so the angles of elevation of the top of a tower from 2 points at a distance 4 meter and 9 meter complementary. So if this is our angle theta, then this will be 90 degrees minus theta. So the thing which is asked in the question is height of the tower. So how to find it is, first thing we should do is we should name the points. This is point A, this is point B, this is point C, this is point D. And now we have let angle DBA is equals to theta. So from triangle DCB, tan B is equals to perpendicular upon base, which is equals to opposite upon adjacent, which is equals to CD upon BC. Now what is CD? It is H. And what is BC? It is 4. So I can say that tan B, instead of tan B, I will write it as theta because it is theta. So tan theta is equals to H by 4. So now we have found tan theta, which is H by 4. So now we will find, so now you will understand why I am writing cot theta over here. Cot theta will be 4 by H. Yeah. So now we have found this. So from triangle DCA, tan A is equals to perpendicular upon base, which is also equals to opposite upon adjacent. Okay, this one. And which is equals to CD upon AC. Okay, so what is a CD? It is H. Oh, sorry, I have forgot that we have to also write, and we have also let CD is equals to H. I am taking CD as height. Maybe you were confused. And now this is equals to H upon 9. AC is 9. So instead of A, I can write it as 90 degrees minus theta because its value is that. So this is H by 9. So now what is tan 90 degrees minus theta? Tan 90 degrees minus theta is equals to cot theta. So cot theta is equals to H by 9. So now what we have found cot theta over here? 4 by H. So 4 by H is equals to H by 9, and then H square is equals to 36 and H is equals to 6. So the height of the tower is 6 meters. So now we will move towards the next question. The angle of elevation of a jet plane from a point A on the ground is 60 degrees. After a flight of 15 seconds, the angle of elevation changes to 30 degrees. If the jet plane is flying at a constant height of 1500 into root 3 meter, find the speed of the jet plane. So from a point A, the angle of elevation to the jet plane is, just a second, angle of elevation is 60 degrees from a point A. They have given the name. After a flight of 15 seconds, the angle of elevation changes to 30 degrees. So after flight of 15 seconds, after traveling some distance, the angle of elevation changes to 30 degrees. This became 30 degrees. If the jet plane is flying at a constant 1500 into root 3 meters, then find the speed of jet plane. So this will be also 1500 into root 3 meter. So now we will name the points. This is point B, this is point C, this is point D, and this is point E. So what we have to do is, now we have some common thing from here. No, what we have to do is, now we know that we want to find the distance BC. We want to find BC. So what we have to do is, for finding BC, we have to firstly find tan A from triangle ABE. So from triangle ABE, tan A is equals to perpendicular upon base, which is equals to opposite upon adjacent, which is equals to here BE upon AB. So which is equals to, BE is equals to 1500 into root 3 upon AB. So now why have I chosen tan A? Because here perpendicular and base were related, and if we find the value of AC and if we subtract the value of AB, then we will get the value of BC, what we have to find. And now we got that tan, instead of A I can write for triangle ABE, angle A I can write 60 degrees, which is equals to 1500 into root 3 upon AB. So tan 60 degrees is root 3, which is equals to 1500 upon root 3, into root 3 upon AB. And now after cross multiplying, AB into root 3 is equals to 1500 into root 3. Into root 3 and into root 3 will get cancelled, and AB is equals to 1500 meters. So we have got AB as 1500 meters. So now the thing we have to do is, now we have found this main thing. Now we have to find something another AC. We should find BC. So from triangle ACD, tan A. Now here for triangle ACD the angle is different of angle A, and for triangle ABE the angle of A is different. So our tan A here is perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to CD upon AC, So now what we can do is, now we can write the value of CD, which is 1500 into root 3. You can see over here 1500 into root 3. So what is AC? You can write AC as AB plus BC. Which is equals to 1500 into root 3 upon 1500 plus BC. The value of AB is 1500. So instead of A, I can write here 30 degrees. So tan 30 degrees is equals to 1500 into root 3 upon 1500 plus BC. Now what is the value of tan 30 degrees? It is 1 upon root 3, which is equals to 1500 into root 3 upon 1500 plus BC. Now BC plus 1500 is equals to 1500 into 3 after cross multiplying. After this, BC is equals to 4500 minus 1500, which is equals to 3000, which is equals to 3000 meters. So now what we have to do is, now we have found that now we know one thing. Speed is equals to distance upon time. So here our speed is equals to 3000 meters upon 15 seconds time. So this will be 1, and after cancelling this will be 200. So speed is equals to 200 meters per second. Or now if we multiply, if 60 seconds, we know that 60 seconds is equals to 1 minute, and 1 minute is equals, 1 hour is equals to 60 minutes. So if we multiply 365 with 200, we will get in kilometer per hour. So if we multiply them, we will get 72,000 meter per hour. So but for kilometer in kilometer per hour, we can write it as 72 kilometer per hour. This is 72 kilometer per hour. So this was the speed of the jet plane. So we will move towards the next question. So this is the angle of elevation of the top of a tower from the foot of the building is 30 degrees, and the angle of elevation of the top of the building from the foot of the tower is 60 degrees. What is the ratio of heights and towers, ratio of heights of tower and building. So in this question what we have to do is, first we have to draw a diagram of a building over here and a diagram of tower, and the angle of elevation of the top of a tower from the foot of the building is, just I will make a big drawing so it will be visible. So this will be 30 degrees, and from of the top of the building from the foot of the tower is 60 degrees angle of elevation. And now what are the ratio of their heights? So to find this, what we have to do is, firstly we have to give the names to the points. This is point A, this is point B, this is point C, this is point D, and this is point E. So from triangle ABC, what is tan C? Tan C is perpendicular upon base or opposite upon adjacent, which is equals to here AB upon BC. So instead of tan C I can write tan 60 degrees, because it is angle C is equivalent to 60 degrees. So tan 60 degrees is equals to AB upon BC, and tan 60 degrees is equals to root 3 which is equals to AB upon BC. And now from here we can conclude AB is equals to root 3 BC into BC, and we can conclude and now we can conclude BC is equals to AB upon root 3. AB upon root 3. So now what we have to do is, from triangle BCD we have to take tan B, which is equals to perpendicular upon base, which is also equals to opposite upon adjacent, which is equals to here, which is equals to CD upon BC, so instead of angle B I can write 30 degrees because it is equivalent to it. So tan 30 degrees is equals to CD upon BC, and then tan 30 degrees is equals to 1 upon root 3, which is equals to CD upon BC. So here, from here we can conclude that BC is equals to root 3 into CD, and now we have found the value of BC as AB upon root 3. So AB upon root 3 is equals to root 3 into CD. So actually the height of the building is AB and the height of the tower is CD, and now AB is equals to 3 CD. So AB upon CD is equals to 3, and then CD upon AB is equals to 1 upon 3. So we can say the the height of building is to height of tower is 1:3. This is your final answer. And now, thank you for watching. Please subscribe to my channel. Kindly share this video. And I will meet you in the next video. Till then, take care. Bye bye.